Okay, welcome back. Let's continue our part 2 on the Kirchhoff voltage law. Uh, okay, let me get my mic piece correct. Okay, now Kirchhoff voltage law states that the algebraic sum of the voltages that across if you have a closed loop path or a series circuit, right? The resistors like this, as you can see, R1 and R2, the sum of voltages across the circuit here is equals to 0. So what it means is this. So this is the example. Now you need to know that the current that flows into the resistor will exhibit a voltage V1, and if the current pass through the resistor R2, you will exhibit a voltage V2, and the supply voltage is E. So let's take a look at this example. Maybe this one will be better. The application of Kirchhoff voltage law is shown in the circuit below. Let's say, for example, if you have a voltage at 10 volts, right, you have two resistors. One is a R1, which is 1 ohm. Another resistor R2 is at 4 ohms. Okay, so the total sum of voltages the sum is equals to 0 because your supply is 10 volts, which is here, and the voltage that drops on the resistor R1 is 2 volts, as you can see, and the voltage V2 that is dropped on resistor R2 is 8 volts. Therefore, the total sum of 8 minus 2 minus 10 is equals to 0 volts. Or in other words, you can express it that 10 volts, which is the supply voltage, is equals to the sum of the two voltages that is dropped on the respective resistor R1 and R2, which are equivalent to 2 volts and 8 volts. So this is a simple example of a Kirchhoff voltage law. Alright, okay, I will pause here first and I'll stop the recording, and then we will proceed to the next one.